In this video today we are going to study about the Riemann sums and the definite integrals, and we will see that how can we apply the concept of Riemann sum in order to find the area under the curve. So basically, in order to understand the Riemann sum, you should know that the area under the curve should be divided into different or equal number of the rectangles. So let's try to understand with the help of a graph. Let's try to understand the logic of Riemann, how he calculated the area under the curve. When he was asked to calculate the area under the curve, what he did, he thought that let's divide the area into some rectangles. So firstly, he divide the rectangle, the area. For example, let's suppose I will show you here that the graph was given to him and he divided the area into only one curve, one rectangle. He created or he made one rectangle, okay, and he calculated the area of rectangle. Means you know that the area of rectangle is actually length into width. But what he observed, that in this calculation, what is happening, that he is calculating more area than the area of the graph, which means that the area which he is calculating, he is giving him error. It is not exactly equal to the area under the curve, but it is giving somehow some area. So what he thought, that let's, rather than dividing or calculating the area of this curve by making or dividing into one rectangle, let's divide that area into some more rectangles. So look at this as how we are showing you in this graph, that this graph is divided into four equal parts of the rectangles. So he calculated the area of first rectangle, then he calculated the area of second rectangle, then the area of the third rectangle, and in the end area of the fourth rectangle. How he calculated? By using the normal formula, that is length times width. So you can see that this width for each rectangle is same. So let's, here in our case, each the width of each rectangle is 1. Now he calculated the height. What you have seen, that when he calculated, some of the area is left behind, and here he calculated extra area. So this area and this area, after the calculation, they are equal to each other. So similarly, in this way, he calculated the area of each rectangle. Then he added the area, and he said that this area is approximately equal to the area under the curve. But what have we observed? That again, the margin of the error is more. Okay, so what he did after that, he divided that same curve into more rectangles. Now the width is lesser, okay, width is lesser, and the area under the curve is divided into more rectangles. Again he calculated the area, and after calculating the area, again he found some margin of some errors in his calculation. Why? Because he's saying that yes, still the area is not exactly, or minimizing the error is equal to the area under the curve. So what he did, after that he practiced again and again by dividing the curve into many small rectangles. So what have you seen, that after dividing the curve into many rectangles, the area get minimized, the percentage of the error is reduced. So look at the first graph and look at the last graph. If we analyze the graph, we can see very easily by our visual eyes, by our naked eyes, that the area or the margin of error is minimized by by dividing the curve into many rectangles. So as much as possible you are so the number of the rectangles increased, the margin of the error decreased. So this was the logic behind the concept of Riemann's sum. When he says, when we say that let's divide this curve into equal intervals, okay, into equal subintervals. So those subintervals is said to be or is denoted by the n. Now, in order to calculate the width, we take the starting point or the lower limit and the end point, that is the upper limit. And in order to calculate the width, what he did, he divide the starting point and he subtract the last point minus the starting point and divide it into the subintervals. Okay, this is when the subintervals have the equal width. Okay, equal subintervals, when the curve is divided into equal subintervals. So in this way, we find out the delta x. Delta x is the width. Now there are different kinds of the Riemann sum, especially the left-hand Riemann sum. So left-hand side Riemann sum. Also we have the right-hand side Riemann sum and one more, that is midpoint Riemann sum. So what is left point of Riemann sum? So look here, you have been seen that 1, 2, 3 and 4 rectangles are in front of you. For the left hand, we will take the points, the left points of each rectangle to calculate the height Okay, and the curve is made like this so that the curve, the left side is at the edge of the curve. In the right hand curve, in the right hand side or right hand side Riemann sum, we are going to join the right hand side of the rectangle. So in this case, you will see that the right corner of each rectangle is lying on the curve. Whereas the width, this is one width. Okay, the width you can see they are equal, they are of equal parts. They are of equal parts, whether it is a left Riemann sum or it is a right Riemann sum. Now in the midpoint, what he did, he took the midpoint of each rectangle. So he took the midpoint of each rectangle and after that he created the curve. Let's explore the concept of Riemann sum by by solving one of the example. So here in this example, they are giving us the value of the y, which is equals to x squared plus 1. And the starting point is 0, which means the a. The ending point of the graph, which we have to study, is the 2, that is b. So the first step is, and the subintervals is 4. Okay, now the first step is that to calculate the width. So in order to calculate the width, we will use the formula b minus a divided by n. Whereas our b is 2, a is 0 and n is 4. On calculating it, we will get 0.5. It means the width of each rectangle is equals to 0.5. So let's just try to understand by using a number line. So the starting point is 0 and the ending point is 2. And we have to divide it into 4 equal parts. So 1 part, 2 part, 3 part and 4 part. So look at this. How can we write the values here? 0 plus this width 0.5 gives us 0.5. Then this 0.5 plus this 0.5 gives us 1. Then 1 plus 0.5 gives us 1.5. Then again 1.5 plus 0.5 gives us 2. So this is the width. Now, in order to calculate the y values, let's try to make a table x and y values. So in order to get the y, we will use our equation. Now what is the x value? In order to take the x value, you should focus that what is the question saying to calculate the area using the left Riemann sums idea. Left Riemann sums means that each rectangle's corner should be the left, means the left hand, the left corners of each rectangle should be studied. So the left corner of this rectangle is here. Left corner of this rectangle would be this point. Left corner of this rectangle would be this point. And so I have point 1 point, 2 point, 3 point and 4 point. So left corner of this rectangle is this one. So I will calculate my length on 0, 0.5, 1 and 1.5. So I will write here 0, 0.5, 1, 1.5. Calculated by putting these values in instead of x, put these values of x one by one and you will get these answers. 1 square plus 1 and then 3.25. Now our formula, in order to calculate the area of the rectangle using the Riemann sum, the formula is again length times width for each rectangle. So for example, the first width is x1 and f of x1 is our length. Then you have second width, f of x2. Then you have third width, x3, and then the length, f of x3. Then you have x4, the width, and f of x4. Now put the values one by one in this given equation. So x1, x2, x3 and x4 are 0.5 because the width from here till here, here till here, here or here is 0.5. And for f of x1, you have calculated the length, that is 1. x2, as I said, this is 0.5 and you calculated the value of y, that is 0.25. On x3 again 0.5 and you already have calculated the length at 1, that is 2. And then the fourth corner is 3.25. Write all in the calculator. And so 1.25, 2, 3.25 and 1. The answer will be 3.75. Now only try to understand that how you will make this graph. Just a rough graph, okay? Just a rough graph. So on the 0, the length is 1. On the 4, on the 0.5, the length is 1.25. On the 1 corner, the length is 2. On 1.5, the length is actually 3.25. And on the 2, the length is, if you calculate on the 2, the length is 5. So now first of all, make the rectangles. Okay, on these points, try to make a rough rectangle. So let's try to make a rectangle. So let's join it. 1 second. So using this desk, the digital pen, very difficult to make the rectangle. So let's try to make this rectangles. Okay, create rectangles as you like, but make sure that all the points are connected. Make sure that all the points are connected. Now in order to make the curve, you have to use the left side of each rectangle. So you are going to use, you have to use the left side of rectangle. So you connect the left side, means the graph should be, the left corners of the graph should be on the curve. So this is the kind of the curve. Now what have you seen, that the answer whatever you will get is overestimated. Why overestimated? Because look at this. This part you have to calculate the area of this part, right? But you see that there are some rectangles which are overestimated, which are calculated more. Okay, so the answer will be overestimated because the graph lies under the rectangles. So the answer is 3.75. For the next question, what you have to do, you have to calculate the same calculation but solve for right Riemann sum. So already you know that delta x is 0.5. We already have calculated our, we already have told you that our points are 0, 0.5, 1, 1.5 and 2. Now we have to take the right corners. Okay, so for the right corners I am going to use these points, because if you look at the first rectangle, this is the right corner. Second rectangle, this is the right corner. Third rectangle, this is the right corner. And for fourth rectangle, this is the right corner. So we will write the formula, that is x1 f of x1, x2 f of x2, x3 f of x3 plus x4 f of x4. So length into width. So x1 will be what? Starting from here, 0.5. x1 is actually the width. So 0.5, the distance of each rectangle is 0.5. So x1, x2, x3 and x4 will be 0.5. They will not change because the distance between each rectangle is 0.5. Now, when the first point is 0.5, answer was 1.25. So we already have calculated before, if you remember, x here and f of x1. So when it was 0.5, answer is 1.25. When you put 1, you will get 2. When you will put in the main equation 1.25, you will get 3.25, sorry, 1.5, not 1.25, 1.5. Okay, and when you will write the 2, you will get the 5. So put all these values in the equation. So on 0.5, I have 1.25, then I have 1, I have 2, I have 3.25, and then I have 5. So if I write all this in the calculator, I will get 5.75. Okay, if you want to create the graph, just have a look on creating the graph just to understand quickly that my first point on the 0, it was 1, then 1.25, then on the 1 I have the 2, and 1.5 I have the 3.25, and on the 2 I had the 5. So I was just making the rough sketch. Make sure that all the corners are joined with each other. Okay, but now you are going to take the right side of the graph. So right corner is here, here, here and here. So now again right side corner is here. Again you will see that your answer is overestimated because many of the area is left behind. while calculating the area of the rectangles. Now the last part is that we are going to calculate using the midpoint Riemann sum. So here also only understand the delta x we already have calculated at 0.5. Our subintervals are already is 4. So let's start from here. 0, 0.5, then here 1, 1.5 and the last part is 2. Now when we say the midpoint, so what are the midpoints? The midpoints is this one. This is the midpoint. This is the midpoint between the rectangles and this is the midpoint of the rectangle. So to calculate the midpoint, we add 0.5 plus 0 gives us, divided by 2 gives us 0.25. 0.5 plus 1 divided by 2 gives us 0.75. Similarly here 1.25 and then 1.75. Now calculate again, the width is 0.5. Okay, the width is stay the same. The width stays the same for the rectangles, but the height will be calculated in terms of 0.25. You will calculate on 0.75, calculate the height or the length at 1.25 and 1.75. So calculate the y values at these points. So let's quickly try to calculate these points. Let's try to calculate this point. So when we write here 0.25, our answer is 1.0525. When we write 0.75, our answer is 1.5625. When we write 1.25, our answer is 2.5625. And on writing 1.75 as an x, I will get 4.0625. You can calculate your own self to make sure that the calculations are correct. Now just same thing. Delta x stay the same. That means 0.5. Now f of x1, f of x2, f of x3 and f of x4 will be changed only in this scenario also. Why? Because you will write the heights on the basis of these calculated numbers. So it is 1.0525, 1.5625. Do not round off at all, okay, because they are only 4 digits, so no need to round out, otherwise the margin of the error will be increased more. 4.0625. Now pause the video and try to calculate it. And give me the time also to calculate. So we are going, normally I take the 0.5 as a common and in the bracket I add all these things. So 1.0525 plus 1.5625 plus 2.5625 plus 4.0625 all in the bracket and multiply by 0.5, we will get 4.62. Okay, 4.62 area as a midpoint Riemann sum. Now if you remember, so the area with the left Riemann sum was 3.75, right? In our case, area for the midpoint Riemann sum is 4.62 and area with the right Riemann sum was 5.75. So what is the most suitable area in our scenario is the left Riemann sum. So this is the whole concept of the Riemann sum when some equation is given to you.